So Alexis took X and put it over the 15. So notice how X starts at the 1 arc and it extends to the 2 arced. So go to your other triangle. Notice how 15 starts at 1 arc and goes to 2 arcs. So those are corresponding sides. And when she set hers up, she did the big side and compare a big triangle and compared it to the small triangle. So when we set up our next one, we have to go with the big side on top and the small side on the bottom. All right, then what'd you set up, Alexis?
I did 27 over 10.
All right, so then she put 27 over 10. So let's see why we would have done that. If we then look, come on, there we go. We go from 1 arc to 3 arcs. So the corresponding side that goes from 1 arc to 3 arc is here. So these are also corresponding sides. We have to put the big one on top, that's the 27, the small one on the bottom. That should work. Now, did anybody set it up a little bit differently? Yeah, what'd you get, Victoria?
I didn't multiply it, but I found the scale factors, because I was 2.7, I did 27 divided by 10, and then I was supposed to multiply it by 15, and that.
Oh, that's deep. So you did 27 divided by 10 first?
Yeah.
Good, and then what?
And then I multiplied it by 15.
All right, so what she did is she did 27 divided by 10. So what she did, she even used fancy math words. I like Victoria. She found the scale factor. All right, so the scale factor is she took the one complete set, 27 divided by 10, found that to be 2.7. So the one on the left-hand side should be 2.7 bigger than the one on the right-hand side. So then she took this guy right here, and knows that if I did 2.7 times 15, what's that going to give you? Victoria, did you do that?
I know, I put it on.
Okay. That I need to do. I don't know that one. 40.5. Yeah. All right, so that should now give us 40.5. Let's solve the one Alexis set up. Uh-oh. Did you get a 40.5, Alexis? Good. Go ahead and solve Alexis's. We should be able to solve this. Looking at the homework, we all know how to solve a proportion. Crisscross, multiply, and then solve that equation. There we go. So 10 at, oh. There we go. So 10x would equal, this is 40.5, 405. Divide by 10, and notice how we get the same exact thing. Now, anybody else set it up differently? Because that's actually really good. Kind of set it up that way. Here's the other way I want us to see, because I know people looking at the homeworks, people are doing this a little bit, and I just want to make sure if you're getting this, you understand that it's fine. And it may be beneficial in certain situations anyway. So what Alexis did, she went purple to purple, blue to blue. What we could actually do is set up blue to purple, so put a 27 over an X. So let's just stay in this triangle the whole time, put the blue side over the purple side. And as long as I go to the other side and do the same thing, put the blue side over the purple side, the 10 over the 15. Notice how here 10 and X get multiplied together. Don't the 10 and X get multiplied together there? And then if I crisscross here, 27 and 5 or 15 get multiplied together. Don't they get multiplied together right there as well? So that would produce the same exact equation, the same exact answer. Okay? So a lot of different ways we can set up these proportions. All right, letter B. A little trickier. Take a minute and see if we can do this guy. We did one of these the other day where we had a shape like this. Let's see if we have any sort of a fighting chance to set this one up. We want to figure out what is the length of this big side over here. a little hint, although I didn't draw it great, let me try this real quick. I sketched in sort of how I'm going to explain this. We'll see if you understand why I did this. All right. Let me see what we get here. All right. Here's what I would suggest, especially as we're getting used to these, is separating these into two separate figures, because this for a lot of people is going to be confusing. I would hope letter A was nice, even if we didn't fully remember it after the long weekend. Once you see letter A and see how we set this up, either one of these versions, that you're thinking, okay, I remember that, that's not too bad, because these are two very clearly separate shapes. Triangle 1, triangle 2, they were not touching each other. When you look at letter B, now it's sort of one shape, right? There's only one shown graph right here. So for us to make it look like letter A, what we would just do is we could take this small triangle in here, and that's what I've drawn here. And then don't we at the same time have this big triangle here? And I just drew that in the bottom right-hand corner, because now we have what looks like letter A as two distinct triangles. If you can do it without splitting it up, if you can still look at this shape and not freak out about what this shape looks like and not split it up, totally fine. We'll find out right now if we did. But what that should allow us to do, now let's label some things first. If I look at the small side, we have the entire small triangle as a 5. This was a 3. This was a 4. All the markings on the small triangle we knew, at least all the sides anyway. So we'll mark those. If we look at the big triangle, we know this big long side right here is 15. So if I go to the big triangle, that's this side right here is a 15. The bottom of the big triangle, we're a little bit out of luck. We know from right here to here, that's 4, but we really have no idea what this length is. So this is a problem for us right now. We don't know what that is. However, if we look at this big side of the height, for the big triangle, the height, we know that that is your x that we're trying to solve for. So having split that up, first of all, we understand how we split that up. We can see this. See now, once it's pulled apart, if you weren't sure at the beginning, set up a proportion that would allow us to solve this problem. Now that we're split up, now this should look like letter A. This now should, crossing my fingers when I say that, be an easier problem to set up. All right, so set that one up real quick. See if we can set up a proportion that's going to work. Find room where I'm going to write it. Jake, question, or you're going to give it to me? Question. Yeah, go ahead. All right, so go set up this proportion. I'm gonna go Paige. What do you got, Paige? Good. So she put 15 over 5, and then what was the other one? Good, x over 3. I'm gonna guess a lot of us doesn't have one that looks exactly like that, but that should be good. So kind of understand what she did. She took 15, which is in the big triangle, the big long side in the big triangle, and then it's corresponds to the longest side in the smallest triangle. So she put the 15 over the 5. Because she went big to small, so she put the bigger triangle side over the small triangle side. The same thing better be true over here. So if we look at that triangle, find the corresponding side. She has to include x, right? You better include the x. So the x is the big triangle side, so she put that on top, and then that corresponds to 3. That's the small triangle's corresponding side. All right, that should work perfectly. All right, anybody else set it up differently? Here's the, what did you get, Paige? If we cross multiply and then nobody's afraid to tell me what they set up, we should get what? Good. 5 times x is 5x, 3 times 15 is 45, and our answer is what, Paige? All right, so if you got 9, even if yours looked differently, you set it up correctly. All right, I would have had a little bit different arrangement of that. That's why it's okay to kind of set this up a little bit differently. All right, anybody else set it up differently? Sure. All right, as long as you get 9, totally fine. All right, next one, set that one up. Letter C. Yeah, a little trickier. Oh yeah, good call. Yeah, this 12 on your paper, know that it's this side right here. You can't pick up yours and move it, but maybe cross it out and write it there. It looks like the angle currently, so put it on that side. All right. The reason I consider this one to be a little trickier is because it's a little bit harder to see which sides correspond to each other. So I would strongly suggest using your markings to understand which sides correspond. And what I mean by that is, what I'm going to do is mark this side over here. This side connects the 1 arc with the 2 arcs. So if I draw in 1 arc to 2 arcs in yellow, that means I go to the other side. Whichever side in that small triangle is the 1 arc to the 2 arc, that corresponds to the one I currently have marked. So that corresponding side has to be this one. Those two sides correspond with each other. I have to include the x in my proportion because that's the answer to the question. So now think about what that would have to correspond to. The blue side corresponds to the single arc and this unmarked angle. So if I go to the big triangle and I go from the single arc to the unmarked angle, those are my 2 corresponding sides in the big and the small triangle. Now you can set up, a variety of different proportions with this as we go to set this up. Let's see here, Jake, what do you got?
X over 15 equals 12 over 20.
Good. So again, different arrangement than what I would have had, but perfectly correct. He did this X, so small triangle blue side to the big triangle's blue side. And then he said he's going to go 12, so that's the small triangle's yellow side, comparing it to its corresponding side of 20. So you'll know this is correct, because either route you took, you should have a 20 times an x. So as long as your proportion has the x getting multiplied by 20, and then the 15 getting multiplied by 12, so that you end up with this equation, then your proportion was correct. Even if your numerators and denominators were flip-flopped, the fractions were backwards, whatever, as long as you get these two products, then you had it set up correctly. And then we can divide, and you should get 9. All right. To finish the notes on an easy one, hopefully, do letter D. This would be the one that I would hope we can now all get somewhat nicely. So set up this, get your answer, and we can feel good about ourselves. Caitlin, give me a second.